everyone. My name is Virag Mody. I am a technical writer here at Gravitational. I want to thank all of you for taking the time to attend this talk on how to securely access compute resources in cloud environments. So this talk is largely based on a white paper that we had released about a month ago and has gotten some attention from some pretty big companies, IBM, Dell, Palantir, what have you. So we figured let's take this topic, put it into a virtual event and see how that goes. So for the most part, we'll be taking a look at this topic from a conceptual level. But if you do stick around towards the end, I am going to talk a little bit about how applying these principles to SSH certificates sort of proves why SSH certificates are safer than using SSH keys, which again, we sort of all know that, but these principles provide us a pretty good framework for why that is the case. My goal is by the end of this talk, you'll have not only an understanding of some of the principles that you can start thinking about using, but maybe some of the techniques as well to apply them. So just quickly before we begin, a little more about Gravitational. We are an open source company. We have two main products, Gravity and Teleport. Teleport is the sort of inspiration for this talk. Teleport is a way for developers to securely access the tools that they need without getting in their way. Basically, Teleport is just sort of a gateway that stands between your servers, your Kubernetes clusters, soon to be your web applications like Jenkins as well. And all users have to do is sign in to the gateway or enter the gateway using their SSO provider, and Teleport automatically applies permissions and controls based on information gathered from your IDP. So anyway, you're not here for that. So let's get into the fun stuff. The first thing I want to do is sort of better define our topic. So when I wrote the title, right, like how to securely access compute resources in cloud environments, it's a very broad, vague, sort of general title. So let's narrow down the scope a little bit. The first thing is secure access. What do I mean by secure access? I just mean like any type of reliable way to authenticate and authorize. So we know who is accessing what resource and what are they allowed to do. Like authentication, authorization, they're not new by any means, right? They've been around the world for networking for decades. We've had passwords, but the context in which I'm talking about secure access is against a much richer data profile. So not only like a password or like a hexadecimal string, but much more robust information. And we'll talk a little bit about where that information comes from and how it can be used. The next segment has to do with compute resources. So by compute resources, I just mean any type of infrastructure resource that has a processing capability. And like in the cloud, we're mostly talking about like virtualized resources, right? Servers, clusters, apps, databases. But then you also have your hardware component as well, whether it's like desktops or other sort of devices in your network. And then finally, cloud environments, which sort of seems like the most self-explanatory, right? We're talking about like hybrid cloud, multi-cloud VPCs, but more broadly, I just mean any environment that's focused on providing high availability and has that sort of like resilient architecture. And so another way to phrase the title, like how to securely access compute resources in cloud environments, is how to authenticate and authorize access to elastic infrastructure. Okay, so is this actually a problem, right? Like, how do I know that? How do you guys know I'm not trying to just sell you on some vaporware product, right? There are two trends that I want to highlight here. The first is the abstraction of the IT stack. And the second is the decentralization of the competing resources in your IT stack. And I think this image by Gartner on the screen really captures the sentiment. Right, you have all these different like X as a service hosting solutions that basically take the different components, the different elements of your IT stack, they compartmentalize them and then they abstract them using microservices or orchestration. And so you have this extreme type of abstraction where everything gets neatly packaged and is ready to deploy on any server located anywhere in the world. And it's a similar story with decentralization, right? Like with Elastic Cloud infrastructure, we're spinning up resources up and down all the time, right? Like say one of your regions has an outage, you need to set up servers in another region, or maybe your West Coast servers are fetching data from the East Coast. God forbid, using like edge devices, right? And then at that point, you've sort of scaled your network exponentially. And so on its own, abstraction decentralization, they're not a problem. It lets teams move quickly and get a lot more done than ever before. But the way that we define and then enforce our access policies isn't designed to be compatible with ephemeral infrastructure, right? Like the principles that we base access policies on assume that we have some degree of relatively stable static infrastructure with discrete groups of who is accessing what, and that we know these things in advance. And nothing proves this idea more than the fact that we still rely on networks for this exact purpose, right? We expect networks to help distinguish between who are the trusted actors and who are not, and then define our access policies based on what the network information says. And when I talk about networks, I like to think of this concept of the map is not the territory, right? So what does that mean? Well, it means that the map is not the territory. A map is an abstraction, right? It is a substitute for the territory. In this case, when talking about networks, a network is an abstraction of what we think is happening in our system, what we think users and machines are actually doing. But that's not the same as what they are doing, right? Because again, the network is an abstraction. It is a representation of behavior. It is not the actual behavior. And so when we take a look at what we're asking the network to do and what information we're asking it to provide us and what it's actually capable of doing, you start to see some incongruencies. So for example, infrastructure was much more static in the past. I think that's something that all of us can agree on. And what we would do is we would use substitute variables as placeholders for behavior. Right, we would use IP addresses, we would use ingress ports, like basic authentication patterns, and those would substitute what was actually happening in the network. But nowadays those variables aren't reliable because they're constantly changing. Right, infrastructure is dynamic, and so for a network to keep pace with what's happening in the system, in the territory, there needs to be this constant updating of firewall rules, networking rules, routing rules, IP tables, access control lists. And you can automate that as much as you possibly can, but there's always going to be a lag. There's always going to be a delay of what your network is telling you and what is actually going on. And by no means am I saying that like network security is irrelevant, right? If anything, I think network security is going to become more relevant as cloud tends to move past adolescence. But my point is, we can't rely on the network to tell us what's actually happening. We can't rely on the network to tell us what's actually happening. We need to rely on another source of information. Those substitute variables are no longer sufficient. We have to track actual behavior. How do you do that? So that brings me to this slide, which is arguably the most important slide of the deck because it answers the question of how do you securely access compute resources in cloud environments? And the answer is to separate the processes of authentication and authorization and let the resources themselves enforce the access policy, not the network. And you can start doing this by applying these four principles. They're the principles that we built Teleport with, and they're the principles that we believe are required for secure access in modern environments and modern infrastructure. So the first principle is base decisions on identity, not secrets. This is, again, probably the most important principle. That's why it's first. Another way to say this is like, how can we grant access based on who and not what? And there's good reason to ask this question, right? I see secrets as having two major flaws. The first is the flaw that we all know, right? The one that is pretty commonly understood, which is that if the secret falls into the wrong hands, it can be used maliciously, it can be used negligently, and it can cause some type of irreparable damage. But I think the lesser known weakness of secrets is the fact that a secret isn't a reliable source to authenticate against. Now, originally, secrets were meant to just be a one-to-one mapping of a secret to a person, right? You are a person, you hold one secret, that is your secret, that's nobody else's. But in reality, we know that's not the case. Secrets are shared all the time, especially when you're talking about distributed environments, right? Like you're not going to issue a unique certificate for a unique credential for each developer for every instance that you spin up. That's just not going to happen. You're going to end up leading to secret sprawl. And so what happens is developers end up sharing secrets, and then you have secrets that are misplaced. You have people accessing resources when you don't actually know who's standing behind the secret. And so what happens is you have a host that is expecting one person on the other end of the secret, right? They're expecting a specific person to be on the client. But if you authenticate and authorize all in one step, you don't really know who that person is, right? There's no way for you to understand, is the person on the other side of the secret, is the person that holds this SSH key, the person that I actually want accessing this server. And that's what brings me to identity. Because identity is a much richer profile than a dumb secret, right? There's information, there's more information you can authenticate against. You have your teams, your roles, your groups, the date, the time, right? All these extra data points that can form authentication decisions. And people can't share identities, right? You only have one. I am Virag. There's no one else that is Virag, just me. And so when you have an identity store where you're centralizing all this identity information, you have a single source of truth for all information that's up to date, that's accurate, that's representative. And so if you're an enterprise, maybe you're using something like Okta, maybe you're using something like Active Directory. If you're using an open source project, you might be using something like Keycloak or Glue. But the point is that by using a centralized identity store, you're taking the burden of authentication off of the network and applying it to an IDP that is tasked with that exact challenge, right? One of their tasks is to authenticate. You don't have to authenticate by proxy by using some type of secret. And there's some benefits for authorization as well, right? It's not just authentication. With identity information, you can enforce certain granular access controls and permissions. So with identity, you can prescribe certain groupings, certain roles, certain privileges associated with that identity, right? So you can define who is an intern, an SRE, a sysadmin, and things like that. And all these identities have their own set of variables, their own unique identifiable information. And so you create these very granular enforcement policies that derive their instructions from the identity information. And you can set very specific rules like developers can't access production environments after working hours, or some permutation of that rule. And that's not something you can do with a key, and that's not something you do with the secret, because you need to have a detailed profile of who the client is and know how those details map to a specific access policy. Again, that's not something you can just do with a hexadecimal string. The next practice is to make it easy to use, right? So if you're attending this talk, you've likely heard of the term DevSecOps. Whether you approve the concept or just think it's marketing fluff isn't really the point. What's important to recognize and account for is that developers are busy, right? Teams are busy. They move quickly. They have multiple deadlines. They push dozens of updates in a day. And so if you make it difficult for them to access the tools that they need to do their job, they're going to find a way to make a backdoor, right? They're going to create a backdoor. And that might be hard coding secrets to an application. That might be generating private keys that you don't know about. It can be sharing secrets that aren't meant to be shared, what have you. And so even if you have the most well-intentioned and the strictest security policies in place, if those controls are complicated or inconvenient, inevitably you're going to create a less secure state. For example, I was speaking to a friend the other day that works at a pretty prominent banking company, right? Like they have a multi-billion-dollar market cap. And to access something as simple as Jenkins, right, they have to set up a VPN. They have to put in a change order, wait for it to get requested, approved. They have to switch from their personal account to a provisional account. They wait for a generated password and then use that password to access Jenkins. That workflow sounds terrible, especially if all you're doing is trying to look at a dashboard. And so they're going to find a way to make that easier for themselves because they need to, right? Like they're developers, they need to move quickly. They don't have time to go through all these, jump through all these hoops, no matter how secure that makes things for them. And so the second principle is just make it easy to use, right? Make it developer friendly, account for that as part of your design. And that will make sure that developers follow the policies that you want them to and not just tell them to. The next principle is don't trust private networks, right? Only assume there are public networks. And that might seem like a drastic point to make, but I don't think that's too far from the truth nowadays, because we're exposing our private networks more and more to public domain, right, to the public internet. We have all these like API services that we use. We have like an X as a service, these public cloud-driven applications that have sort of become the new norm for operating. And we've expanded the surface area for our internal network and exposed it to the public. And that makes it very difficult to assume that we know someone is part of the network versus someone who is not, right? Someone who's allowed to enter versus someone who's not. And so if you get away with this idea that private networks exist altogether, it solves two very important problems. And by private networks, I'm not saying that you don't have internal networks. I'm just saying that you don't assume a certain level of security just by being inside the private networks. And that solves two problems. So the first is having poor internal security protections, right? Poor internal network security. So for example, let's assume that we can actually have a private network where people within the network are allowed to be there, right? Like they sort of made it past this bouncer. And at that point, there shouldn't be a need for strict internal policies, right? No one should be able to enter the system that is not allowed to be there. So why do you need internal controls? Well, the reality is that's not the case, right? One of the best examples that I like to use is the 2014 Target hack. So basically what happened was hackers were able to enter Target's internal network, and they got access to Target's HVAC data processing network, which was provided by like a third-party supplier, right? This isn't something that Target built internally. This is something that they're relying on a vendor for. And so these hackers got access to that vendor's network that connected to Target's network, and they were able to traverse horizontally from HVAC data processing all the way to payments processing. And they were able to steal just like thousands of credit card details. And there's absolutely no reason that you should be able to move from HVAC data processing to payment processing, right? There's just no reason, right? There should be some type of internal security controls to prevent that from happening. But because people assume that within a private network, the people that are allowed to be there, or the people that are in there are not tracked with such diligence as people that are outside the network, these things tend to go unnoticed. And so if you assume that the entire network is public, right, you're going to just naturally bake those controls in by default because you can't assume that anyone is safe. You can't assume that they are not a malicious actor. The second problem, just assuming no private network solved, has to do with encryption. So encryption best practices will tell you to just encrypt everywhere all the time, no matter what, right? Encrypt data in transit, data in processing, data at rest, all of it. But again, if you can assume that there is a private network that at a certain point you've made it past the security scrutinization, then you can relax these measures. But if you assume there are no private networks, then that's not a possibility. You have to encrypt all the time just by default, which will make your security folk, really happy. The final principle has to do with centralized audit and logging. I like to think of logging almost as like a hygiene habit, right? So you can think of it as like maintaining poor Git habits. If you have poor Git habits, then as you grow, as things become more complex, it's only going to become more difficult to unravel that gigantic mess. And the same thing is true with logging habits. And nowadays, it's extremely important to make sure that you centralize all of your logs sooner rather than later, because there's never been more logs to aggregate, right? Each progressive layer of abstraction creates its own set of logs. You have your server logs, you have VM logs, application logs, Kubernetes logs, containers logs. And every time you spin up an instance, even if it is for just like 5 minutes at a time, you're creating this entire cross-section of the IT stack of logs. And it's very easy for those logs to get lost in the noise, especially if it is only for like 5 minutes at a time, but those logs could contain crucial information. So similar to identity, you want to centralize all that information where you can aggregate, parse, analyze, dispose of, all of this stuff with your logs just in one place. And this isn't just a security problem, right? So going back to this idea of DevSecOps, you have developer teams that are working with security teams that are working with operations teams, and they all need to operate with the same information, right? There needs to be information symmetry. And so if you have these logs that are siloed in their own locations, it's going to be very difficult to make cross-functional informed decisions about what needs to happen next. Another advantage I just want to mention has to do with compliance. So nowadays, compliance is almost a cost of entry into a lot of markets. So whether it's SOC 2, whether it's HIPAA, whether it's PCI, GDPR, it's good to have some type of centralized logging monitoring, almost as a prerequisite to pass those certifications. Right, the last thing you want to do is get audited and not know where your logs are. So recapping this just a bit. The way to securely access your infrastructure is by separating the processes of authentication and authorization and letting the resources themselves enforce those access policies. And to demonstrate this, I think for the remainder of this talk, I want to take these principles and apply them to SSH certificates. And if you've worked with SSH at all, you know that generally certificates are safer than keys. They're just more reliable. But if we look at these certificates through the lens of these 4 principles, it becomes immediately clear why that is the case. And my hope is that you'll get a better sense of how this framework can be applied to whatever sort of authentication authorization methods are relevant to your company. So before you start, let's just quickly summarize what certificates are. I think for the most part, all of us know this, so I'll make it brief. SSH certificates are just another way to connect to a remote shell, right? They serve the same function as SSH keys, but unlike keys, they have a lot more properties, right? They have identity information, principals, permissions, they have expiry dates, and like additional metadata that keys don't have. And another advantage of certificates, almost a feature, is that you don't have to track the keys that are generated, right? You don't have to track the certificates that are generated. All you need to do is track the key of the certificate authority that generates those keys. So instead of having a laundry list of authorized keys or known hosts, all you need to do is have the public key associated with the certificate authorities. And you know that anytime a certificate is presented that matches the public key, you know that has been signed by the private key. And so you can just authenticate against that. So taking a look here on the screen right now, we have sort of a standard like open SSH certificate, right? Going through the top, we have our certificate public key. Below that, we have the public key of the certificate authority that signed that certificate. And below that, we have this key ID. And a key ID is just an alphanumeric string that gets logged whenever a user presents this certificate. In this case, our key ID is a company email. And this certificate belongs specifically to one of my colleagues, Gus. And this gives us more visibility into who exactly is presenting this certificate. Because again, all this information gets logged if you're using verbose mode. And we can even like revoke the certificate, right? So we can say that Gus at gravitational.com is not allowed, his certificate cannot be authenticated or cannot be authorized. And so say you have like a person that has left the company, this makes it very easy for you to offboard them. Same thing with onboarding. The validity field shows us how long a certificate is valid for. Keys, as we know, are they're valid forever in perpetuity, and that's sort of one of the reasons that makes them dangerous. But with certificates, you can set a specific expiry period to limit the access and ensure that the certificate can't be used in perpetuity like a key. Below that, we have principals. So principals are basically just your Linux or Unix users that the certificate is allowed to authenticate as. But the important thing is that this is just more identity information, right? This is more information that gets logged. And instead of creating a key for each individual user, you can now aggregate all those user logins into one certificate. Below that, we have extensions. So extensions just either permit or revoke certain privileges. On the screen right now, we have 5 permissions. Any of them can be revoked until you have this permutation of possibilities available to you. So let's actually evaluate this certificate against the 4 principles that we discussed earlier. The first one is to base decisions on identity and not secrets. Now, certificates are issued to both users and hosts, right? Or you can issue them to both users and hosts. And these users and hosts will have uniquely identifiable information. Right? We saw this when we looked at the key ID for this user certificate, and then you'd also have like a key ID for a host certificate like AWS East production environment, right? As well as information, as well as like principles that a user can log in as. And these certificates can further be subdivided into groups that have specific permissions like port forwarding or agent forwarding. And that's just way more information than just a key. And all of that comes from having identity, from mapping secrets to identity. The second practice has to do with ease of use. So once you have a certificate authority up and running, it's pretty easy to automate the process of requesting certificates just by like integrating that into some of your DevOps tooling. So say that you need to like dynamically open a shell, you get granted a certificate with the right permissions based on something as simple as your email. And encoded within the certificate is also expiry, so you don't have to worry about secrets just lying around, waiting to be taken advantage of. The next thing is the third point was like, don't trust private networks. Just assume that all networks are public. And for the most part, whether it's like applications, whether it's servers, VPNs are sort of the go-to method for secure access. But again, just because you have a VPN doesn't mean that VPN is secure. Instead, if you have a certificate authority that protects both the user endpoint and the host endpoint, you've now created this closed system. And finally, with centralized logging, all of your requests are going through just a single certificate authority, or maybe 2 if you have your user and host. Meaning that you have this like central bottleneck that aggregates all of the logging information into one place. And fields like key ID, principals, failed login attempts, those add adds much more information and a much richer profile of information to your logs. And so the purpose of this exercise, right, it's to frame SSH certificates or to show how SSH certificates are better than keys by framing them in the context of these 4 principles. If you're still skeptical about this, which by all means you should be, anytime someone tells you something about security, always question them. But if you are uncertain, I suggest you try this exercise with your own setup. Right? Ask yourself, am I basing my decisions on identity or secrets? Is it easy to use? Am I trusting the network to do something that it can't reliably do? Where are my logs going? And if you can rethink the answers to these questions, see how the end result is different than what you started with and whether or not that's better. So for the most part, that concludes this presentation. As I mentioned earlier, this talk is based on a tech paper. So if there's anything that you want to revisit, if there's anything you want to read more in depth about, feel free to check that out. And if you're interested in modernizing your authentication and authorization features for your servers, Kubernetes clusters, your web applications, free for you to check out Teleport, where it's open source. You can download it, you can play around with it. Just check out gravitational.com/teleport. And with that, I think that concludes this presentation. Thank you for attending and have a great day.